right, today, everybody, we are starting the conic sections. And by the way, the 4 conic sections are a circle, an ellipse, a parabola, and hyperbola. Today, we're specifically dealing with a parabola, this shape that is made when you take a slice of a cone, coming diagonally to its base, you create this parabola right here. So we're going to be working with parabolas. Now, your parabola is either going to be opening up, or it could open down, and it can also open to the right, or it can open to the left. So right now, here's some notes. Every single parabola has different pieces. All right, you have the vertex. By the way, this is the vertex right here. Okay. You have what's called the focus, and the focus is right here. All right, you have the axis of symmetry. By the way, the axis of symmetry is what splits that parabola perfectly in half right there. There's your axis of symmetry. You have a directrix. The directrix is directly underneath the vertex right here. That's your directrix. And then you have a special side that goes straight through the focus called the lattice rectum. So we're going to be talking about all of these pieces. Something you need to be aware of, everybody, is the distance from the focus to the vertex is going to be the same distance as the vertex to the directrix. All right? So that's something that you need to be aware of. I'll go ahead and zoom in real quick on this picture right here so you guys can see it. So what I want you guys to understand, that whatever this distance is right here, it's going to be the same distance. So the distance from the vertex to the focus is the same from the vertex to the directrix. That will always be the same. So today what we're going to do is we're going to go over to problem number 1, and we're going to take this formula right here, and from this, sorry, not formula, this equation, and we're going to build it into this form right here. Now, right now we've been given x squared minus 2x minus 8y plus 17 equals 0, and we're going to try to change all of this into this form. We're going to have to be able to complete the square. So the very first thing that I'd like you to do is I would like you to take all of this and simply move it across the equal sign. So whenever you move something across the equal sign, what happens to this negative 8y? It becomes a positive 8y. Very good. And that positive 17 will become a negative 17. All right, so that's what I want you to move that across. So here's what we have. We have x squared minus 2x plus, I'm going to put an empty box right there, equals 8y minus a 17 plus an empty box. Now, this box is just simply representing a number that whatever I apply to one side, I have to apply that exact same number to the other side. Now, what I'm trying to create right now, I'm trying to create what's called a perfect square trinomial. And if you've ever completed the square, this will make perfect sense. If you've never completed the square, then you never took Algebra 2 with me. And you probably need to go back and look at how to complete the square. But right now, let me explain to you what completing the square is. If you have a quadratic function, and this is a perfect square trinomial, like this, whatever this is, a perfect square trinomial, the c value will always equal half the b value squared. Now, right there, that probably doesn't make a whole lot of sense, so I'm going to give you some examples of perfect square trinomials and show you how it works. So if you want to write these down, you can. If you don't want to write these down, you don't have to. You can simply watch if you want to. But watch intently, with intention, so that you understand what perfect square trinomials are. So let's give you the most basic perfect square trinomial known to humanity. That's a perfect square trinomial, because that factors to x plus 1 times x plus 1, which becomes x plus 1 squared. By the way, what's half of 2? What's 1 times 1? 1. That's a perfect square trinomial. Let's do another one. X squared plus 4x plus 4. That factors to x plus 2 times x plus 2, which becomes x plus 2, in parentheses, squared. It's a perfect square trinomial. What is a perfect square trinomial? What does it look like? Here's what it looks like. Check this out. I'm going to make some squares. If I have an x and I have an x, what's x times x? X squared. If I have x plus 1 times x plus 1, what's the area? It's x plus 1 squared. I can keep making bigger and bigger and bigger squares where you multiply the sides to themselves, okay? But I'm just going to keep showing you this pattern. If I have x squared plus 6x plus 9, what does that factor to? Hopefully you're starting to see the pattern here, people, which becomes x plus 3 squared. Now, obviously the next one I would probably do x plus 4 times x plus 4. Let's just do a trick here so you can figure it out. X squared plus 18x plus, I wonder what number I'm going to want. 81. Because what's half of 18? And what's 9 times 9? 81. So this sucker factors to x plus 9 times x plus 9, which equals x plus 9 squared. Now, do these only work with positives, or do they also work with negatives? All right. I'll give one example of a negative. Here's your last example. X squared minus... Okay. What do you think my C value will be right here? A positive 64, because what's half of a negative 16? A negative 8. And what's negative 8 times negative 8? Boom. So what is this factor to? X minus 8 and x minus 8, which becomes x minus 8 squared. So here's what I want you guys to understand. If you have a perfect square trinomial, and your a value is a 1, so if your a value is a 1, whatever your b value is, your c value will always be half of your b value squared every single time. And that's what you need to know. All right, I realize that was a lot of extra time and energy, but I hope you understand why I needed that, because I needed that process to fill in this box. What's half of negative 2?
1.
Close. Negative 1. And what's negative 1 times negative 1? Positive 1. So I got to put a plus 1 here. If I put a plus 1 here, I got to put a plus 1 there. Now, what does this factor to? X minus 1 squared. And that's what I needed to do. I needed to get it to this form right here. All right? I had to complete the square. Now, x minus 1 in parentheses squared is equal to 8y. Well, what's negative 17 plus a 1? What does this become? A minus a 16. That's your next step. What do you got to combine? You got to combine whatever number is here with the number that you just put in the box. Now, look back up here. I'm almost done. Is my left side done? My left side is complete. But I have to factor out an 8. So here's what we have to do. We have to factor out this 8, because it's what? Y minus your a value. So what am I going to factor out? I've got to factor out an 8. So what's 8, everybody? What's 8 divided by 8? That's just going to give me a y. And what's negative 16 divided by 8? That gives me a negative 2. So here's what we have left. This is your equation right there. That's your equation. So what I'd like you to do is take that equation and put it at the top of your page on your assignment. Take that equation and put it at the top of your page on your assignment. Because I'm going to do it right now. Here we go. I'm writing x minus 1 squared equals 8 parentheses y minus 2 close parentheses. This is your equation. Underneath it, I'm going to write the standard form that you see on your paper for a parabola. Okay? Does everybody see what I wrote right underneath it to help it interpret it? Okay? The first thing we're going to find, everybody, is we're going to find the p-value. Everybody, you got to find the p-value every single time. Just know that the 4p value, if you look carefully, hopefully you can see that what is 8 equal to? 8 is equal to 4p. So if 4p is equal to 8, what is our p-value in this particular case? 2. So we're not done, but we need that. Just remember, wherever I say, hey, what's p equal to? You say 2. When I say p, you say 2. P. 2. Just don't say 2p. All right. So here we go. Everybody, what is the vertex? That's our h and our k value. Oh, no, they were blank. Yes, it would be 1 and 2. Now, here's what I need you guys to understand of how the formula works. If I take this 1, I grab it. See that 1 right there? I'm grabbing it. And I take it and plug it in for h. What does my equation be? It becomes x minus 1. Then it would make it a positive. Yes. Okay? Now, watch. I'm going to grab the 2. I'm grabbing it. I'm sliding that 2 where? I'm bringing it and I'm placing it right there for the k. And then what does the equation become? It becomes y minus 2. That's why your hk value is a 1, 2. So once you guys find that, if you would, go over 1 and up 2, put 1. And label that point vertex. There's your vertex. Now, if you look at your little chart that you wrote at the very beginning, look where it says focus. What does it tell you about the focus? H, comma, k plus. Look at that. There's your formula, right? Add the k and the p together. So what's our h value still? 1. What's the k value? 2. What's the p value? 2. What's 2 plus 2? 4. There's your focus. So right here, I'm going to go right here, and I'm going to label that the focus. Now, did I tell you guys something about the distance between the vertex and the focus? That's going to be the same distance as from the vertex to what's called the directrix. Okay? So, I wonder what my directrix will be. We'll find out. Let's look at the axis of symmetry. What is the axis of symmetry? What's the formula for the axis of symmetry? X equals what? H. What is our H value, everybody? 1. So if you would please draw a beautiful, nice, straight line at x equals -1. That is your axis of symmetry right there. Put a little arrow. I'm going to label it the axis of awesomeness. Just kidding. Axis of symmetry. Directrix. Is there a cool little formula for your directrix? What does it say? Y equals what? K minus P. What is our K value? 2. What is our P value? 2. 2 minus 2 is 0. So what's our directrix? What's the equation for our directrix? Y equals 0. So what does Y equals 0 look like? Well, Rene Descartes would say, doesn't equal that. Because he's the one that made the Cartesian plane. Right there, that is y equals 0. It's literally on the y. Correction, x-axis. Y equals 0 is on the x-axis. Uh-oh. Lattice rectum. Does anybody know what the lattice rectum is always equal to? That's right, the lattice rectum is always equal to the absolute value of 4p. Huh. What is our p value equal to? 2. 2. So what's 4 times 2? 8. So what's the absolute value of 8? 8. So what's the distance of our lattice rectum? What's the distance? 8 units. So go where the focus is. Count over. 1, 2, 3, 4. Put a point. Count over to the left. 1, 2, 3, 4. Put a point. Then what I'd like you to do is I would like you to draw in, carefully draw in that lattice rectum that passes through the focus. I'm not making this up, people. The lattice rectum will always pass through your focus. That's where it always passes through. That's how it works. And then, build the curve. Like what curve? Watch. Build the parabola that goes through that point, and the parabola that goes through that point. And It's very, 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 very wide. Can you see how wide that is? Okay? So, by the way, in the real world, if you ever see a satellite dish, if you ever wear glasses, you're dealing with lenses that are parabolic lenses, okay? They have a curve to them. Is that right? Satellite dishes, you see where that receiver is on the satellite dish? It bounces off of the satellite dish and goes to a place called the receiver, also known as the focus. All right? When your eyes are blurry, that means there's something about the focus that isn't correct, so you have to get glasses that allow you to be able to see, right? So where the curve is, your focal point, your focus will either go up or down depending on how wide that parabola is. Okay?
That's so weird.
All right, so this is your final answer for all of them. Now we're going to go ahead and look at problem number, zoomed in there, a little too close. Okay. So right now, in problem number 2, we have y squared plus 6y plus 9 equals, you see where it says 12 minus 12x? I'm going to rearrange it. I'm going to put negative 12x plus 12. If your y values are being squared, this is the equation you're going to use. You're going to use y minus k squared equals 4p x minus h. We're using this formula because this time our x value is not being squared. What's being squared? The y value. So this is the formula we're going to use. Now I really like this problem because I didn't have to do a whole bunch of work. Because what is that already built? What is that called? A perfect square trinomial. That's right, it's a perfect square trinomial. Ooh, what is that? Factor 2. That's right. Y plus 3 squared. We already had an example that pretty much looked exactly like this. The only thing I used was x's instead of y's. Now, what am I going to have to factor out of this right here? I'm going to have to factor out a negative 12. So how do you factor out a negative 12? Basically what you're doing is you're dividing this number by a negative 12 and you're dividing this number by a negative 12. What's negative 12x divided by a negative 12? This becomes x. And what's a positive 12 divided by a negative 12? Negative 1. And guess what? There's your formula right there. Well, not formula, I apologize. That's your equation right there. That's your equation. So if you would, please take that equation and put it right there at the top of your page on your assignment. All right, so I'm going to go all the way up here, put it at the top of the page. I'm going to put y plus 3 squared equals negative 12 parentheses x. Was it minus 1 or plus 1? Minus 1? Okay. That's right. All right. And then right above it, here's what I'm going to do. I'm going to put y minus k squared equals 4p parentheses x minus h. What I always do before I start interpreting everything, I always compare the formula or the equation to my other equations. Compare this equation to this equation. What is your vertex always going to be? It's going to be the h comma k. Now be careful, look at this. What is your h value? 1, very good. Which means this. You take the 1, you can take it and literally just plug it right in for h and it becomes x minus 1. But careful, what's your k value? Your k value is a negative 3. Because if you were to take this negative 3 and plug it in right there, what's a negative times a negative? It's a positive. There we go. So, once you have your vertex, plot it. Plot a 1 and a negative 3. Okay. Look at your chart. What is the formula for the focus? What is it? H plus what? Plus P, comma what? Comma K. Uh-oh. We have not found our P value. What is 4P equal to? 4P is equal to a negative 12. You're right. So if 4P equals negative 12, what is P equal to? A negative 3. So my h value, everybody, is a 1. And what's my p value equal to? A minus a 3. What is 1 minus 3? Negative 2. And what's our k value? Our k value is simply just a negative 3. There's your focus. Your focus is a negative 2, negative 3. Negative 2, negative 3. And I'm going to put my focus right there. I'm going to label it. There's my focus. And what's the blue dot represent? What does that blue dot represent? That's your vertex. All right? There we go. The axis of symmetry is a y equals something. What is y equal to for the axis of symmetry in this problem?
K.
Y equals k. What is our k value? There you go. Just draw it in. Y equals negative 3. We're going to go ahead and draw it in right here. Y equals negative 3 is this line right there. That's y equals negative 3. Your axis of symmetry will always pass through your vertex and it'll pass through the focus. Directrix.
Is it like 3 over from the vertex?
You're right. That's right. See how it goes? 1, 2, 3. So it's just what? 3 over from the vertex, but it's going to remember it's going to be a perpendicular line to the axis of symmetry. That's your directrix. Okay. Now, our equation is actually x is equal to a 4. But just so you guys know, x equals, what's the formula for that though? What's it say? H minus what? H minus p. What is our h value? Our h value is a 1. What is 1 minus a negative 3? Ooh, a positive 4. That's where you got to be careful. And last but not least, it says, what is the lattice rectum? And the lattice rectum is equal to the what? The absolute value of 4p. What is the What is the absolute value of 4p equal to? It's equal to a what?
12.
Right? A positive 12. Because the absolute value of a negative 12 is a positive, which means from here, you have to go up. From the focus. 1, 2, 3, 4, 5, 6, and down. 1, 2, 3, 4, 5, 6. That is a very, very, very long distance. It makes this parabola very, very, very wide. Okay? So there's your lattice rectum, and from your vertex, everybody, you're going to draw your curve through that point. You're going to draw your curve. That's not a very good curve. Right here. Now, tomorrow we're going to continue with this. We're going to talk about, I forgot to tell you guys about the definition of what actually a parabola is. So before you leave, what I'd like you to do is look on the very, very, very back page. Okay? Look at the back page. And I want you to look at this picture right here. Does everybody, I accidentally copied, look at the full tiny hand right there, so unfortunately I copied the hand when I did this. But you guys see, from the focus to a point, the distance from any focus to a point on the parabola will be the same distance as from that point straight down to the directrix. So this is the final thing I would like you to understand before you leave today, and have a wonderful day. So hold on. I want you to understand that this distance right here is the exact same as this distance right here. So the distance from the focus to any point on the parabola is the same distance as that point to the directrix. Y'all have a wonderful day.